Alright, good evening. This problem is pretty straightforward. Had some time to talk to a friend and realized that's making it a little more complicated than needed to be. So key facts that still remain the same is area of a triangle equals pi r squared. Okay? And then we also have similar triangles here because, as we talked about, when two lines intersect, the interior opposite angles here are the same. So this triangle and this bottom triangle that are inside of this circle, these two triangles have a similar angle here. And we also talked about that since the diameter equals 20, the radius is equal to 1/2 diameter, so that means the radius equals 10. So that means each side of this triangle sides right here, are 10, which means it's an isosceles. And then the additional rule that we need to know is what angle points opposite of those sides. So these angles right here, which in terms of the picture are A, B, C, and D. So angle A points to the side across from it, which is 10. I'm just making this a little larger. Angle B points across to the side opposite of it, which is 10. So those two angles must then be, since their sides are the same, then the angles must also be the same. And since as we talked about previously, since these interior opposite angles are the same, that means these two triangles are similar. The technical term is congruent, and in fact they're exactly the same. So that means that C and D, the angles there are the same, which means A equals B equals C equals D. Now, that's all useful information because that helps simplify this portion a little bit, but it doesn't help us find out what those angles might be or to eliminate. There's still a lot of possible angles that they could be, right? So one other principle to discuss is all the angles in a triangle add up to 180. So if you have some triangle, E, F, G, this angle, and this angle, even if they're all different, the sum of them, angle E plus angle F plus angle G, all equals 180 degrees. Okay? So in an isosceles, though, it's interesting because two of the angles, as we proved up here, are going to be the same. So that means for an isosceles, this whole formula can be simplified to read, since two of them are the same, right? Let's say E and F, for example, right? So we have this example right here. I'll redraw the triangle from the picture. Right here we have A and B, and we don't name this center triangle anything, so I'm going to go ahead and name it now. I'm going to name it X. So we know that angle A and angle B plus angle X equals 180 degrees. But these two are the same. So because it's isosceles, right? Because their opposite sides are the same. So as a result of that, we can say, in fact, 2 times angle A, or 2 of angle A's, or 2 of angle B's, plus angle X equals 180. So this is useful because this eliminates essentially each triangle one of the unknown variables, but we need to go a step further, right? So how do we get to the portion of finding what I'm calling angle X? Well, degrees, talking to my friend and from my experience, degrees, the whole purpose of them comes from ratios, in fact, right? So if we divide a circle into 360 degrees, that's just portions of that circle. So let's talk about that. If you need to, go ahead, copy down, pause the video here, copy down all of the triangle stuff. I'm going to go ahead and remove that now. Alright, so we still need these principal pieces of information up above, so I'm going to keep those up there for now, okay? So if I take each of these pieces that we had previously, A equals B equals C equals D, okay? And the angle that we talked about, I'm just going to rewrite some key pieces right here. So these two are the same for isosceles. Then the total formula we had was A2 times angle A plus angle X, if this is X, equals 180 degrees. Okay? Well, seeing the circle as a whole here, right, it's just like slices of pizza, right? So if we take a slice of pizza out, if I cut this into, let's say 1, 2, 3, 4, 5, 6 pieces, right? Well, then each slice of pizza is 1/6 of the pizza, right? Well, since a circle has 360 degrees on it, then I can simply take 1/6 of 360 degrees to find out how many degrees the angle is of the corner of that slice of pizza. Obviously, we don't do this when we cut pizza up, but this is a useful analogy for this problem. So I can take 1/6 of 360, right, and divide that, and I will get how many degrees that small portion is. So you can just take any calculator, right, and you just multiply across. So 360 times 1, and then divided by 6 equals 60 degrees. Well, we can use this relationship of ratios and slices of a whole here, because in the problem they give us the area of the shaded region and they exclude this little tiny slices. So really this is almost like a pizza problem, and they're giving us all the area of these pieces, which allows us to find out what the missing area is of these two slices, and then we can find the ratio. So since A equals pi r squared, and we know r is 10, then essentially it becomes A equals pi, and we just put 10 in for r here and square it, so 10 times 10 is 100. A equals 100 pi, or pi 100. Well, we know that the shaded area is 80 pi, so 100 pi minus 80 pi gives us 20 pi. So the slice of missing pieces is equals to 20 pi, and there's 2 of them. So if we divide that by 2 for the 2 slices, then each piece is 10 pi. So now you can create a ratio. You can say 10 pi over 100 pi, right? And that easily reduces because you have one slice, or this slice up here is 10 pi out of 100 total pi. So that can easily reduce. Pi divides out, and now you have 10 over 100. And 10 over 100 can easily be reduced by dividing the top by 10, the bottom by 10, so that becomes 1 over 10. So now we have our ratio. Now we know that our pizza is essentially our big circle up here. It's been divided into 10 pieces using the size cuts that they made here. So just like we did up here when we had a pizza divided into 6 pieces and we found out how many degrees that corner part was, we can do the same thing with 1/10, or if it's sliced into 10 pieces. So I take 1/10 times 360, and that's going to equal, same thing as we did before, 360 times 1, and then divided by 10, kind of straightforward, 36 degrees. So that now we finally know our missing piece. We know this interior angle right here has to be 36 degrees based on the way that they sliced this pizza. Okay, if you want, take a moment here and pause the video. I'm going to go ahead and clean up all the degree stuff we used. Okay, but the key note here is the missing piece is 36 degrees. Okay. So now that we know that top piece, and remember we had created a relationship where it's 2 times the angle A or B or C or D, because they're all the same, plus the missing angle X equals 180. Well, now we know what the missing angle X is, right? So we can just substitute that. So I'm going to start over here. 2 times the angle A plus 36 degrees. I just substituted for X here. 36 degrees, because we solved for that a second ago, equals 180. So now it's just solving. So minus 36 degrees from both sides, right? So 180 minus 36, 144. And you can see now why they baited some of these answers. So this, going to the next step, right, this equals 2 times the angle A. And these cancel, they become 0, equals 144. So finally, to solve for angle A, we just divide by 2 on this side, since they're multiplied, divide by 2 on this side. That takes us to the next step. So this goes to here, and this goes to 144 divided by 2, 72 degrees. So this becomes angle A, because those divide out. This equals 72 degrees. So finally we know what A is, but that's not what they ask for, right? They say what's A plus B plus C plus D. Well, again, we created this relationship up here based on an isosceles triangle and congruent similar triangles, the same triangle reflected across each other, across here. This is the same as this. So we said A equals B equals C equals D. So that makes our life easy, because now that we solve for A, we know B, C, and D. So you can just add 72 to itself 4 times, or you can just say A plus B plus C plus D. Well, 1, 2, 3, 4 equals 4 times any one of those angles. I'll say A in this case. So 4 times 72 degrees equals 288. So check that with your GRE answers, but I think that properly captures the thinking behind this problem. Big picture review that's challenging behind this is you need to know the geometry of interior opposite angles. You need to know the geometry of an isosceles triangle and how the sides relate to the angles opposite of the sides. And then you need to comprehend you need to know the formula for area, the relationship between radius and diameter, and then be able to set up a ratio of areas in order to find out the degrees in the circle. I hope that helps.